Assalamualaikum. My name is Nur Zamira binti Azmal and my metric number is AN250068. And to begin our presentation, let's take a look at the introduction and the specific study area where we have selected our analysis. As you can see from the photograph, on the right, our focus is on the standard pedestrian walkway. This is functional structure designed with three primary goals, providing a roofed shelter, offering shade and protection from the elements, and ensuring a safe, concrete paved path for pedestrian movement. Looking at the technical dimension, the roof section we are analyzing measures 2.33 meters in wide by 4.18 meters in length. This roof is supported by vertical column that stand at a height of approximately 3.13 meters. Essentially, this structure serves as our real-world model. By identifying these physical components, the roof, the column, and the pavement, we can establish the geometric foundation needed to calculate how the structure behaves under pressure. This leads us directly into the mechanical consideration we will discuss in the next slide. Moving on, we must consider the engineering factors that keep this structure standing. Our analysis categorizes the force into three main types. Dead loads, which include the weight of the roofing materials themselves. Live load, accounting for maintenance workers or transient weight. Wind load, which represent the lateral force the walkway face due to its open air environment. The core purpose and importance of this study is to apply the fundamental principle of statics. We aren't just looking at a walkway, we are analyzing a system in equilibrium. We will be performing a detailed moment analysis and examining force distribution to ensure that the vertical columns can safely support the load without failure. Ultimately, by understanding how these forces interact, we can identify potential design improvement. Our goal is to use this engineering insight to support better decision making for similar infrastructure, ensuring longevity and, most importantly, pedestrian safety. Thank you. I am now ready to move into the specific calculation for our finding.
Hello everyone, my name is David Empali Jason and my matrix number is AN250051. Today, I will explain the problem identification for this structure. My explanation will cover the structural system used, the forces acting on the structure, as well as the constraints and simplifications applied in the analysis. Okay, so this overall structural system is a steel frame portal type walkway canopy. It consists of vertical steel columns that support horizontal beams. Secondary purlins are installed above the beams to support the metal roofing sheets. Together, these components form a complete load-bearing structural system. The beam system includes vertical and horizontal steel beams. The horizontal beams resist bending and shear forces, while the vertical columns transfer loads directly to the ground. And then the secondary purlins help distribute the roof load evenly to the main beams. The third one is building wall. This structure is an independent system and is not bounded or concerned by any neighboring buildings, meaning it doesn't build with other buildings, nor they nor they uh, nor they build together, meaning that it builds independently without any other construction or building around this structure. Therefore, all loads are resisted internally by the structural frame without relying on external support. The last one for infrastructures and elements are the ground and pavement. This structure is supported by the earth and acts as its foundation. The ground is assumed to be stiff and strong enough to withstand all vertical and horizontal reaction forces transferred from the columns and roof structure. Hello everyone, it's me again, David. And then right now I will explain about the definition of forces. This roof structure is subjected to several types of forces. There are the self-weight of the roof acts as a uniformly distributed load in the vertical downward direction. Wind loads that act horizontally and perpendicular to the roof, hence creating lateral forces. Another one is these forces generate vertical and horizontal reactions at the supports. On the There are a few forces that acting on the vertical poles. They, these forces are three main forces that act on the vertical poles. First is axial compression caused by the self-weight of the roof. Second is shear force due to wind load acting horizontally. And lastly is moment reactions that are generated by the combined effect of vertical and horizontal forces. The next one is ground reaction. The vertical and horizontal forces from the roof and columns are balanced by the ground reaction. These ground responses are important to maintain the overall stability of the structure and prevent movement of failure. Another one is pedestrian loads. Pedestrian loads act on the pavement and can be represented as either concentrated or distributed loads. This is because how people walk around the structure is not constant. For example, it can be on the left and it can be on the right or in the middle. Although these loads are mostly dynamic, their effect on the roof structure is indirect and mainly influences the ground reaction. Yes, so- Hello everyone. Uh, for my last slide, I will explain about constraints and simplifications. First, the roof and vertical poles are assumed to be rigidly connected, allowing efficient load transfer without distortion. The columns are firmly fixed to the ground, preventing any translational or rotational movement. The ground is also assumed to provide sufficient stability. The last one from me is simplifications. To simplify the analysis, wind load is treated as a uniformly distributed horizontal load, and the self-weight of the roof is treated as a uniformly distributed vertical load. Dynamic effects from pedestrians and vehicles are ignored so that the analysis focuses only on static equilibrium conditions. That's all from me. Thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Fitri Ibrahim, AN 20043. So I would like to explain about analysis. So we have here is gravity load analysis. It's about the slab identification, design load, interior beam, and H beam. So for slab identification, we are so our monument is a walkway with a roof on top. So we using it's actually qualified as a one-way slab, but actually we didn't use a slab, but it was a metal sheet. So metal sheet is automatically a one-way. So one-way slab is for simplification of it. So the ratio is 6.63. That is greater than 2. And that is design calculation. So design load is calculation as 1.463 kilonewton per meter square. It's the both of dead load and live load with the assumption of safety and other load, and also interior beam A and B support the main span and transmission a total load of 7.56 kilonewton each on each beam. And lastly, H beam support the overhand and transmitted a total load of 5.067. There is also a calculation if you want to see it more detail. There is a calculation on the slide. Next is a mainframe analysis. So our structure is model main beam supported by pin A and roller B, and its apply load point load transfer from a secondary beam is point 1 and point 1 and point 2 is 7.56 kilonewtons, and point 3 is the H beam, so it's less than point 1 and point 2 is 5.067 kilonewton. So the equivalent result is AY, the pin is 8.297 kilonewton, and BY, the roller, is 11.89 kilonewton. So the critical force, the maximum shear force occur as a support B is 11.89 kilonewtons. If you want more detail of the calculation, you can see the calculation on the right side. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Imran bin Asri, my case number CN250142. For this analysis, several assumptions we made to simplify the pedestrian walkway canopy into a statics-based structural model. First, in terms of structural assumptions, the pedestrian walkway is considered as an independent steel frame canopy consisting of roof beams, secondary purlins, and vertical steel columns. The structure is assumed to be statically stable and properly connected with rigid beam to column connections to ensure efficient load transfer. The vertical columns with an approximate height of 3.13 meters are assumed to be fully fixed at their base, providing adequate resistance against bending moments caused by gravity and wind loads. All structure members are also assumed to behave within the elastic range throughout the analysis. Next, for loading assumptions, the roof system with dimensions of approximately 4.18 meters by 2.33 meters is modeled using uniformly distributed loads to represent its self-weight and permanent loads. Due to the roof geometry, it is assumed to act as a one-way spinning system where loads are transferred from the roof sheets to the secondary beams and then to the main beams. Wind load acting on the structure is idealized as a uniform distributed horizontal loads, while pedestrian loads on the pavement are excluded since they do not directly affect the roof structure. Or loads are treated as static and dynamic effect are neglected. In terms of environmental and ground condition, the structure is assumed to be exposed only to the normal weather conditions with effective drainage preventing excessive water accumulation on the roof. The ground is assumed to be rigid and stable, allowing the column base to be treated as fixed support without stalemate or rotation. Finally, this simplification justify as the allow the application of equilibrium equation to clearly analyze load transfer, internal force, and support reactions with which align with the main objective of this static-based study. That's all for me. Thank you.
Ya, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Abi Hamid. My number matric is CN250044. So I will present about a conclusion. First of all, summary of finding. For the summary of finding, the study focused on analyzing a pedestrian walkway canopy using static structural principles. The structure was identified as a statically stable system consisting of a steel frame roof supported by vertical columns. The roof loads were transferred efficiently from the secondary beams to the main frame and then to the ground through the columns. Interior beams, labeled as beam A and beam B, carried equal loads due to having similar tributary areas. In contrast, the H beam carried a lower load because it supported a smaller roof area. The shear force and bending moment diagrams for all beams indicate acceptable structural behavior with no excessive internal forces observed. In addition, the calculate support reaction satisfied the conditions of static equilibrium, confirming that the structure can safely resist the applied loads. Okay, the next slide is about conclusion on static principles. In conclusion, this project clearly demonstrates the application of fundamental static principles in analyzing a real-life pedestrian walkway structure. The principles of equilibrium, where the sum of force and the sum of moments equals zero, were applied to determine reaction force, shear force, and bending moments acting on the structural elements. Free body diagrams were used extensively to simplify the structural system and to clearly identify load path and force interaction. Although several assumptions and simplifications were made, they were appropriate for an academic static analysis and allow a clear understanding of the structural behavior. Overall, the analysis confirms that the pedestrian walkway canopy remains stable under the assumed static loading conditions and highlights the importance of static as a foundation in civil and structural engineering design. That's all from our group. Thank you.